Okay, so let's continue. I'm recording this, and therefore I'll put it on the YouTube page so you can catch up if you can't do it right now. So, and we'll see if this guy can help, but I don't know. Okay, so the first step was just so we did calls, column viewer, and then we just selected everything except for validation. And I forgot to check this little box. It doesn't really make a difference. We're just looking at the summary stats, but to get the same printout on the PDF, if you choose show quartiles and then hit show summary, then you should get these other quartiles too. So this will be the same thing you see on the page right here. Okay, so it shows those extra columns. Okay. Now, we'll look at the data, and so we'll see there's three categories or three categorical variables. Oh, this will tell us what the thing is. So state, international plan, and VM plan, and 15 continuous factors. They can be used as predictors. Okay, and so there's no missing values. Um, so this is the number of voicemail messages, all right? And churn is the two category variable where we see that about 14% of the data is for those who have churned. So that shows us there. Okay. Now we can get the distribution of churn. So how do we do that? Oh, okay. So if you just click on churn in this little section and hit distribution, okay, that'll show you the percent who have churned and the percent who have not churned. So it shows you here that about 14% have churned and about 15% have churned and about 85% stayed with the company. Okay, so all we did was just click on the churn variable and then distribution. Yeah, about 15% have changed to another company, right? Okay, and then we can get the distributions of the other ones if you want. So this shows the distributions of the predictors. And to get that, all you got to do is choose those and click on distribution. So let me go back there. Hello.
How you doing?
Good. How about you?
Good.
Yeah. So let me show you. So when they're license expired,
Did it match? No.
yeah. So it says the license expired. So this message is kind of the license is just a text. So yeah, so calls. Use everything.
What did you get?
It's from a. Well, there's a link on that, but there's a back to it. Okay. All right, so if you want to get the next step, just the other distributions, I'll just show that when you're here. Oops. And you choose everything again. Okay, and you can choose any of the ones you want to show the distribution. There you go. Okay, so okay, so this is all being recorded, so you can, if you're having some tech issues, you'll be able to see it. But so we can look at the relationship between the predictors with the mosaic plot, and to do that, we can do analyze, fit x by y. Okay, so I'm going to close this, close this. Okay, so oops. Up here, analyze, and then fit x by y. Okay. Okay, let's select churn, which is do they churn or do they not, as the y response. And all the other predictors as x. Okay, so let's choose not state, but let's choose all these like that. So you want account length all the way through number of service calls. And we're going to put those in the x factor. So do that and then hit OK. Okay, we should get this. And then the things we're looking at are these mosaic plots right here for international plan and for VM plan. Okay, did that part work? Yeah, okay. So what you can see here is we're looking at like, does this make it more likely or less likely to churn? So you'll see that if they have an international plan, they are more likely to churn, right? Because this is no international plan, this is yes. And so there's a bigger percentage of the international plan holders that leave. And so that's probably because at least a long time ago, the international minutes are very expensive. And so if they can find a plan that gives them cheaper minutes, international, which are a big expense, they might switch. Okay. Yeah. Okay. And then what's the VM plan again? Oh, okay. Voicemail. Doesn't everyone have Okay, so customers that have an international plan are more likely to churn, and customers that have a voicemail plan are less likely to churn. So this one makes sense. This one I don't think would make a difference much, but you can see the distribution for yes over here, like quite a bit, like almost like 50, 45% or so. So international plans at least used to play a big role, but this doesn't look like it's too much. Okay, let's put the model. So we're going to do a lookup of all the variables. Variable. And so also make sure that the add-in feature I showed you is there. So up here, add-ins, you should see the random seed reset. So if you don't see that, you need to download that file from Blackboard, this one. Where's Blackboard? Did I close Blackboard? Oh, yeah. Study guides and week 7 and this random seed reset thing. So if you download that and just run it, it'll install the little add-on feature into your JMP, hopefully. Yeah. Oh, okay. I'll show you how to. Oh, yeah. Oh, yeah. I haven't updated this. Yeah. Oh, are you using Windows 11? Oh, okay. So how many people are having issues with the license? No one else? Did you get? Oh, The next one does use interpret. Okay, All right, so next time, just to be safe, everyone has to bring in their own desktop. Just kidding. All right, let's continue. Where we Okay, so we got these little mosaic plots. All right, close that. Oh, do we look? Oh, I was doing a little add-in thing. Okay, so double check you have the add-in. Yeah, so you should see the add-ins and then the random seed. So we're going to use that when we run the model. Okay, so let's get that thing out of the way. Okay, so analyze, predictive modeling, and then neural. Okay, so we're going to run a neural model a bunch of times. So analyze, predictive model, neural. It should look like this. Okay, and you should see the little random seeds thing. And if you see that, you want to type 1,000 in there. All right, so put 1,000 in the random seed. Okay, so 1,000, yeah. So everyone sees the random seed thing. Okay, so put 1,000 in there. And let's put churn as the Y response. And let's put all the other ones from account length all the way to number of customer service calls. So everything from here to here goes into the X factor. Okay. Okay, so you got account length, international plan, voicemail plan we know. Number of voicemail messages, day minutes, day calls, day charge, evening minutes, evening calls, evening charges, night minutes, night calls, night charge, international minutes, international calls, international charge. Some of these are the same. Like, I don't know why you need international minutes. Well, I guess. And the number of customer service calls. I bet that one's important. Okay? All right. Now, let's hit. So make sure this is 1,000. This is that. The window? The Yeah, so analyze, predictive modeling, and then neural. Okay, so we got that. Let's hit, okay. Oh no. Yeah, okay. And it should take you to this little option. I think we're going to leave the defaults. All right. Where we got, we'll change, the things we're going to change later on in the research questions are the hidden layers. But for now, we're only doing one layer, and we're using the tan H function. But we have the option for a second layer, and we have the option for linear or Gaussian that we'll do later. But for now, you can leave the default, but it should, just to double check it's the same, you should see a bunch of zeros except for the 3 there, which means that we have um, one hidden layer with 3 nodes, which are of this function. Okay, and you can hit go, and this should be the model. And we'll look at the results here. So we should see little results, yeah? Is exhibit 7? Where's my, no, I just hit, yeah, just leave it as the default. And then go. Okay, so we are, yeah, so it should look just like this. So we're using this one, the hyperbolic tangent function, but you could also use a linear or a bell-shaped Gaussian. So the little dialog box looked like this. We didn't change anything. And then we're going to get exhibit 7, which is the little network diagram. Okay, so to do that, you can click on this little red triangle. And I think there should be yeah, first one, diagram. Okay, you can see how all of the predictor variables are connected and they go to a hidden layer with 3 nodes to try to affect the output variable. Okay, it's a little diagram. It's kind of, everyone got that? Yeah. Okay, now, okay, so if you look here, looks like mine's a little bit different than the printout, but not too much different. Um, so this is the training and this is the validation, right? So this is the R squared. Here's the misclassification rate. So it should be about 8%. Okay, and this little thing, the confusion matrix, which is kind of confusing to understand what they're showing, but what they show is the percentage of like misclassification errors. So false is good, or true is good, but the number of times it was false but predicted true, or true but predicted false is incorrect. Okay, so about almost all the falses were correct, but about 60% of the trues are correct. Okay, so the reason it's harder to so like false means like they actually turned and it was also predicted, right? Yes. Yeah, exactly. Yeah. 2%, yeah. Right. Exactly, yeah. So if so if you look at them all, so false, they were actually false, it predicted it false, 98%. Or they were false, but it predicted true was only about 0.02 or 2%. And then if they were true, but it predicted false, 40%, whereas the other 60%, yeah. So it's harder to predict if they're going to churn because there's less of them, right? So most people don't. So it gets that pretty, but it's hard to know what variables cause people to churn. But it got it right 60% of the time, which is, that gets you elected president. Oh, sorry. Yeah, I meant to look at this one. So yeah, this is not a problem, but this is when, well, yeah, I mean, it's a problem because I'm not a problem, but it's showing that 40% of the time it was wrong. Yeah, not wrong, just couldn't predict it. Yeah, couldn't predict. Yeah, exactly. Yeah. Okay, so we can get the ROC and lift curves. If you do hit the red triangle and see the ROC curve, and also if you hit it again and choose lift curve, okay. And what I believe there's a little definition which is useful right here. Yeah, so did we get different numbers? So our misclassification rate was 9%, was that right? About eight, it was 8%. Close enough. Okay, and then it says customers who actually churned 47% of the time the model predicted correctly that they would churn. So we got worse than, or we got better than, oh, we got different results. Huh. I think, is everyone getting what I'm getting? Yeah. Okay, so the printout looks a little bit different, but Yeah, they got half and half, and we have a better model than it shows in the printout. Okay, and then so the lift curve. So lift is a comparison of the churn rate for a given portion of the data when they're sorted in order of predicted probability compared to the churn rate for the entire population. Okay, so that essentially means, so they interpret one of them here. It essentially means that, like, here's the proportion of the population, the 10% quartile. They're 5 times more likely to churn than the model would predict. So it's like the lift or the added or the added multiplication. And so if you look at 10% of the data, then they're 5 times more likely to churn. Or as you look at all the data, it gets more correct. Okay. So I think this is one of the questions on the thing. Okay. Yeah. Oh, sorry. This one describes it nicely. So from the lift curve here, we see that for rows that are in the top 20% of the sorted probability, churn equals true. There are roughly 4 times more churners than we'd expect if we do 20% of customers at random. So if you don't sample a big enough size, you're not going to get it. Your results are going to be skewed, and so you got to get. This is saying you got to get all the customers to get an accurate churn, right? Okay. Now, exhibit 10. So what is this? We can get here. Okay, everybody good so far? Okay. So we got the results, we looked at them, we got the diagram, we got the lift and the ROCs. Now we can get the estimates. So if you click on the red triangle here and then show estimates, okay, you'll see all the estimates here. Yeah, these are the actual estimate. What? Yeah. Okay. Now we can get we can save the formulas for these predictions. So you can do under here, the red triangle, save formulas right there. Okay, and then what that's going to do is put it onto the data sheet. Okay, so if you look over here, it's put some new things on here. So these are the estimates, and then these are the probabilities that you'll churn true or false, most likely to churn, and you can see the formulas. Okay, if you click on this and right-click it, formula, it'll show you how to get those calculations. Yeah, I know, right? It's yeah, I like it too. It's more visual, right? Yeah. Okay. All right. Now let's get the okay. Let's get the categorical profiler and then arrange in rows. And we should get this little picture here. And so this gives a little summary of what we've seen so far. So for customers with international plans, actually, let's get the little. Okay, so we're here, and then let's do the red triangle again, and then categorical profiler, and it should be down here somewhere. All right, and then we want to. They put it so it puts them in rows. They're not just so many across. So if you do click on this little arrow, and then appearance, arrange in rows. You can specify how many rows you want to go across. Maybe 6. Okay, and what that's going to do is do that. Okay, so I'm not sure if we got the exact results that the document got. We did? Okay, so for customers with international plans, you can see that by doing this. See how you drag the little line over? So international plan, yes. Okay, so all of these show uh, how churn is affected by the variables. So this is like account length. So if you have your account's longer, it doesn't it still stays about 60/40. Um, if you're an international plan holder, you churn more. Um, if you have a voicemail plan, you churn less. And it looks like the number of voicemails kind of increases than decreases for some reason. And some of these have weird patterns. If you have more day calls, more more churning. This one kind of goes up. Well, you see the idea is like you can play with little numbers and see like if this goes up or down, what happens to churn. Okay? These ones? Yeah. So this is day minutes, right? Or let's start with this one, number of voicemails. So what that would say is the number the I mean the relationship changes. So let's say when it starts out here. All right. So we're starting at like what are we starting at? About 60/40, right? And so this one would say that if there's no voicemails, then nothing's happened. So let's say you get 10 voicemails, you're more likely to churn. And if you go to 20, it seems like as initially you're less likely, and then as you get more voicemails, that maybe that makes a difference. Then you're more likely. So maybe yeah. So it looks like it's a negative relationship, and then it's a positive one. So it flips it around 13, 15, right there. So from the first 15 voicemail, the first 15 voicemails, you're less likely, and then if you keep getting more voicemails, you're more likely. So maybe that has something to do with like, well, it does a little bit. So maybe like if your company allows more like spam callers, and so if you get a lot of like spam or like yeah, yeah. So yeah, exactly. Yeah, yeah. Okay, and then this one is a little bit is weird too. So first, if you have more day minutes, you're more likely to churn. But maybe at this point you're paying so much you don't care, and so yeah. So the ones that are nonlinear, like this one too, where up to a certain point you're more likely, and then you start, or then you get more. Yeah. So it yeah, kind of interesting. This. Exhibit 15. Okay. All right. So the red triangle under prediction profiler, and then okay. So down here, so right here for prediction profiler, click on that and choose assess variable importance. Okay, so under prediction profiler, assess variable importance, and then independent uniform inputs. Okay, and this, again, I think I got something different, I think, than the printout, but this shows you, do we get the same thing here? Yeah. So it looks like the results are a little bit different on the document, but that's okay. We can just go with what we got. Yeah, same idea, right. So it looks like in predicting churn, uh, voicemail plan is the most important, the one we didn't know at first. Okay, so yeah, and then this is the yeah. Look at it. Well, this one because it's just yes or no, and then daytime minutes, second most important. All right, and then you can see like evening calls. As it goes down, they're less important. Right. Okay. And then the marginal model plots kind of showed basically these things in a more uh, this one, yeah. Oh, in the graph, this one. Oh, down here. Oh, yeah. Well, because it's just yes or no. Like, yeah, it's binary. Yeah, yeah. So the ones that are clear, um, how did the what happened to my thing? Everything changed. Where'd international plan go? Yeah, but my thing just like okay. Oh, there we go. Okay, it just got moved around. All right. Okay. We lose this. Let's save this. So remember this. We do for under model. No, like this. Yeah. Okay. So up at the neural part, click on the red triangle and save script to data table. Remember this? Yeah. And you're gonna do a number of them, so you can call this whatever you want. Neural of churn 1. Okay, and hit OK. And that's gonna save it to the data table. So when you close this, you should see it here. And then if it saved it correctly, I'm just trying to get that thing to there. Okay, so it should be here, and then we double click this. That should bring it back up. So you get all your stuff there. Okay, and then some things might be hidden, but you can open them up. Okay. Uh, yeah. What? Problem? Okay. So we got that. Now, okay, so the questions for the case are down here on page 12. So use the churn data that you did and fit the original one with 3 nodes in the TANH activation function. So you did that. Okay, so A, fit the model described in the case study. We've done that. B, let's fit a model with 1 hidden layer, 3 nodes, and let's use one of the each type in the new analysis, and we'll look at the comparison. Okay, so to do part B, we'll do the easiest way is to go back to the original and then modify it. So if you open this one up, or just, and let's do, we want to, yeah, oh, here we go. Yeah, so up on the neural part, click on this and then redo, and then you can hit relaunch analysis. That should that should take you back here, and everything should be selected, right? And make sure this is 1,000, and everything should already be selected, right? So hit OK, and we're going to change this part. So here, we want to do 1 tanh, 1 linear, and 1 Gaussian. See that? All right. So that's the only change you're going to make. Everything else is the same, but make sure this is 1,000 still. And this is 1, this is 1, this is 1, and there's no second layer yet. We'll do that the next one. All right? So hit it, go. And now we can you can look at how your results are different. A little bit worse in predicting. Okay, you can get any of the things we got before. We got the diagram. We got these things. And then I like the categorical profiler. We can look at that. Okay, and that shows that. And then if you want to compare the variable importance, you can click on this. Where's that? Access variable importance and independent uniform inputs, right? So is it different? Yeah, it's different, right? Way different. Okay, so day minutes, night minutes, voicemail plan were the important ones. And to compare like the predictability, this one, the misclassification rate is a little bit lower, I think. But this one predicted is about the same, right? The predictions. Yeah. Okay, so you can explore that and then save this one. Save script to data table, and we can call this knurl of churn 2. Okay. Okay, and that should be here. So when you open it up, it'll show you have one tanh, one linear, and one Gaussian, and the previous one, 3 tanhs. Okay, we got that? Now the next question, fit a model with 2 hidden layers and several nodes using activation functions of your choice, and how does this compare to these ones? So you can do you can do a different one, but it wants you to fit 2 hidden layers and several nodes. So we want to use the 2 option. So let's go back to the thing, open up either of these. Get this out of the way. Okay, so open up one of these, and let's do redo analysis. Oh wait. Sorry, relaunch analysis. Okay, relaunch analysis. And now we're here again. Okay, so just leave it the same and hit OK. And now in this options, we're going to change these things to do second layers. So what I did before is I just made, so this is the first layer. This is the second layer. Maybe we can do one of each in each layer. So maybe like 1, 1, 1, 1. Okay, so that would mean we have 2 hidden layers and 3 nodes of each type in each layer. Okay, see what I did there? You could do different things if you want, but you have to do at least something in the second layer. All right, let's hit go. Which one? Which one? Oh no, no, you don't have to change that. No. Yeah, all we changed was this part. Yeah, so these are all ones. So one of each type in the 2 layers. And then where this it? 1, 1, 1. I think okay. I think this is it. Yeah, okay. And then if you do where's the diagram? Okay, you can see the second layer, right? So here's the first layer, and here's the tanh. The linear is just the straight line, and the bell curve one is the Gaussian. And then there's a second hidden layer, right? And you can kind of see what they're representing there, right? So 2 layers. Remember before we only had the 1 layer, and these are the different types. That's the you can like compare them, but this is the tanh, the linear, and the Gaussian, and the second layer. So is this one better? Um, it's about the same, huh? Yeah, they're all about 7 or 8, and then they all predict the churn rate about 60% or so. This one's a little like 1% better. Okay, and you can explore like the curves. Predict categorical profiler. And then what if we look at access variable importance and independent uniform inputs? So they're all different, yeah. So number of customer service calls, day charge, day minutes, those are the most important. And look at some of these curves are weird. The customer service calls, first they churn, and then once they get too many, they don't churn. Oh wait, or do they? No, they churn more. Oh yeah, yeah. Maybe sometimes you have to click on it to kind of read it. So this is so as it goes down, they churn more. Oh, so this click on this excess variable importance, and then this one. Okay. All right. So like the ones that have more of an effect have some kind of curve, like these ones, and the ones that don't do much are kind of flat. Like it doesn't seem this does much. Like a evening calls almost no effect, right? So the ones that have more curves show there's more of an effect. Okay, should we save this one? Save script to data table. Call this neural of churn 3. Okay. So there's that one there. Okay, what's next? Okay, D. For the original model, fit in this case study, what's the lift proportion at 0.2? And what's the lift at 0.10? So the original one, neural of churn 1. Where is it? I don't know. Oh, here we go. Okay. So the lift at portion 0.2 is around 4. And the lift at 0.1 is around 5.5. Yeah. Okay, and the lift is interpreted right here. So lift is a comparison of the churn rate for a given portion of the data when the data are sorted in order of predicted probability compared to the churn rate for the entire population. So it interprets and it kind of interprets like this. So remember right here, it showed if it's 20%, there are roughly 4 times more churners than we'd expect if we drew 20% of customers at random. And so um, if you just take a portion of the sample, it's going to give you biased results because it'll predict it like it won't predict the correct amount. So based on what's said here and what's said here, you can kind of see what the churn rate is. So it's compared to the whole population if you don't take a random sample. Okay, and then is that it? Okay, so we did that, we did that, we did that, we did that. Recall that this team is tasked with identifying customers most likely to churn with the goal of developing strategies. Yeah. Yeah. Yes, this one. I think, well, they're both the same. They're both about the same, but yeah. So the 0.2 was about 4, and the 0.1 was 5.5. Okay, so we call this team is tasked with identifying customers most likely to churn with the goal of developing strategies or interventions to minimize the risk of churn. So how can this model be used toward this goal? So you can just put a line or two there to just say like, you want to identify the things that are most important, and the things that are most important, you can focus on that as a company. And if you know if you know like more voicemails makes them churn, give them less voicemails. If you know if international plans are making them churn, then make sure the international plan is not too expensive or something like that. Okay, so for this one, you're going to submit 2 documents. So one, the JMP file. So just save the JMP file. So remember, just do, I think it just saves it, but file, save as, and it's going to save it as a JMP file. So you can save it, the JMP file, as, yeah, first name, last name, case analysis 1. Okay, the JMP file. Then you can also just have a Word document with just some brief answers to the questions. And so all you submit here is the JMP file, first name, last name, case analysis 1 .jmp, and then the second thing, first name, last name, case analysis 1 docx Word document. Just put a few brief answers to those questions that we just talked about right here. Okay, so the JMP file, and then quick answers to these questions. If it's this one, just say that you don't need to. If it just says fit the model, just say model fit, or yeah. Okay. Well, you're gonna save the JMP file, then you're gonna open up a Word document and just uh, answer the questions. Yeah, yeah. Yeah, right. So for this one, 2 documents, the JMP file, and then a Word document with the answers to the questions. Okay? Yeah, if it says like fit, just say like if it doesn't have a specific question, like this one, just say like CJMP file or model fit or just a check mark. I don't know. Okay, so this one, yeah, you don't have to do anything. This one you can just say like you can just list the 2 misclassification rates. For this one, you can compare the misclassification rates and maybe so the things we're comparing, I guess, are the misclassification rates and then this part. So we're trying to see how the misclassification rates are different and how they correctly predict people churning. So if we're just summarizing the differences, just look at the misclassification rate under validation, and under validation, look at this, which shows the model predicts 60% of the people will churn, or the model predicts correctly that 60% of the people will churn. Okay, and this one just put in the lifts, and you can interpret lift. And this one just a few things saying how like Verizon or AT&T could use this model and help it prevent people from churning. Okay. All right, and then turn in these 2 files. Okay, so, but everyone good on this? Yeah. And then this will be recorded, so if you're unable to, you can hopefully catch up. But I don't know why that license isn't working. Okay, any questions on this one? Okay, let's take a quick break and we'll do case two. Yeah, come back at 8 o'clock. Yeah, but you got to do it through the on demand. Yeah. Yeah.
Enterprise binder we're gonna use for case study two, does it have to be that academic spline?
Yeah.
It has to be.
Yeah, it has to be that one because it has the text binding features. Yeah. Hmm. Okay. All right. Should we? All right. So for project two, or for case analysis two, um, what? Yes. All right. Okay. So, where are we at? Okay, so the case analysis 2, study guides, week 7, and there's case analysis 2. The guide, you can open that up. Okay, and for this one, we're going to use the on-demand enterprise miner, so hopefully this works. All right, so you want to click on SAS on demand for academics and sign in, and then you should be here. And then when you're here, everyone should be enrolled in the courses or enrolled in MDA504. And under applications, you want to open up Enterprise Miner. So log into SAS on demand for academics, go to applications, and open up your Enterprise Miner. Yeah, under applications, SAS Enterprise Miner. Yeah. Yeah. And don't expect that to change tonight. Okay. And then if you're able to sign in, it should just be like the regular Enterprise Miner. Okay. So can everyone get to this? Yeah. Okay, yeah, so it should do this. There we go. Okay, and you'll see that like you have your little user number down here. Okay. All right. Okay, everyone got this so far? Okay. Okay, so the project is case study 2. Okay, so we're going to use the text features. And this is going to be there's a data set we're going to have to locate with gas data. And so what this is, so the data used in this case study is hypothetical, but it's based on real data. So there's a fuel stop company with 300 plus gas stations. Um, and we're looking at the fuel company's call center, and we're looking at different features. Okay, and so if you look at the features, okay, so what we need to do, what are we trying to do here? Okay, so we're looking at a bunch of features of this gas station data and trying to group it and gain insight and kind of group different features into what the problems are. So we need this library. So if you're on Enterprise Miner, let's make a new project first. So File, New Project, and there's no hit next. Okay, and you can call this case study 2. I'm going to call it case study 2A because I think I've already done this name. I'll call it case underscore study 2. Okay, so case study 2. And I can't do that. I'll hit next. Okay, and then it's going to put it into your folder. So next. And then finish. Okay, then let's make a new diagram. So file, new diagram, and you can call this case study 2 as well. Okay, now we need to get this data source with the gas station data, and I had to create a separate library because it's on a different. So let's see if it's there, and if it's not, I'll show you how to find it. So do file, new, file, new data source, and then hit next, and then hit next, or sorry, hit browse. Okay, yeah, so we need to make a library where we can see this data source. Okay, so this is somewhat complicated, but it has to be done because the data, you can't upload the data, you have to just find it on the server. Okay, so cancel this. All right, so we're going to make a library locating the data that's shared with the other professor who organizes um, the, what is it called, like permissions. So we want to find this file, gas text numeric data. And to do that, we need to find it in a shared library. Okay, so let's try it. And you also need to know your user number, which is here. So on your SAS on demand page, like your name will be up here on the right. And if you click on this arrow, that's your username. It's you something. And you have to know where that folder is, or you have to know your ID so you can put the library into that folder. Okay, so let's see if we can do this. File, new, library. All right, so say it's create new library and hit next. And you can call it, I'm just going to call it LIB, like LIB for library. Okay, LIB. And then you need to hit right where it says library information, hit browse. And then open up the home folder. It's going to take like a minute because it's slow. So open up the home folder here. And it'll take a second to open. It'll just, no, we're trying to. Yeah, it's not, it's still loading, right? There's still, yeah, so it's opening up the home folder, I think. Or it just broke, I don't know. Um, I think it's still opening or did it work? Yeah, I need. Oh, there. Okay. See, so now we're just get in the home folder. It takes a minute or so. So we're in the home folder. Yeah. Okay. So in the home folder, you have to navigate to your specific ID number, which is this. So go to your SAS on demand, or actually, it's down here too. That's probably easier. So look. So down here on your enterprise monitor, see where it says mine is U59164142. Okay, I'm gonna go to that folder. So look whatever your number is and find the folder here, like under the U section. There's a lot of folders. Yeah, it's not. Okay. All right, okay, see? Here's my number, U59164.142, U59164.142. So find your folder, your ID number, and open it up. So you can't access any folder except yours. So go to your folder and open it, and it should take you inside your folder. No? Couldn't sign in? Let's see. You want to go to the one, so when you go inside your folder, there should be a folder called My Shared File Links. Open that up. Okay, and there should only be one option for the other professor, which is JLead27. So open that up. So inside the folder, it's My Shared File Links, JLead27, and then you should see DM text 13_1. Okay, now that's the folder. So, but you need to change the type here to all files, and then click the folder. Okay, so make sure it looks just like this. It says JLead27. You're choosing DM text 13_1, but you have to make sure the type is all files. And click OK. The name? Oh, the name is, I think it's choosing, it does, just leave it blank. Yeah, just leave it blank, I think. Yeah, that's the one you want. Yeah, no, don't double click it because then it'll open it. You want to have the whole folder. So just inside here, choose that, all files, OK. And it should show the path to the folder there. Okay? Now hit next. And it should say action succeeded. Okay, then hit finish. And now, hopefully this works. File, new, data source, then hit next and browse. And you should see the folder, the library you just created right there, and click on it, and it should have a bunch of stuff in it. Yeah. But it takes a, yeah, well, I have to get back to the, okay, yeah. So did that work? It's a bit slow, yeah. Okay, let me show. Okay, you good? Yeah. Okay, make it move. Okay, so you guys need help? Okay. Okay, so just a second, so you should see the file, uh, gas, gas text numeric data. So that's the one we're going to choose in a second. So make sure you have the file, gas text numeric data. Okay. All right, we're good. All right. Okay, so then choose that one. All right, gas, text, numeric data. Okay. Next. Next. Let's do advanced. So step 8, we'll do advanced. Yeah. Okay. So just do advanced, then next, 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 and next, next, finish. Okay. So we should have our gas text numeric data up here, and let's drag it down. Okay, like we used to. All right. Everybody got this? Yeah. Okay. Now, so the reason why we're using this on demand is because we have the text mining features. And so we want text parsing, text filter, and under text mining, and text cluster. Okay, and then we connect them all, kind of like text parsing. Okay, so the data goes to text parsing, it goes to text filter, and it goes to text cluster. Okay. Then let's right-click text parsing and choose edit variables. And let's change the use of comment 1 and comment 2 to no, like that. Okay. So the use of comment 1 is now no, and the use of comment 2 is now no. And let's hit OK. Okay, now let's run it from the text cluster node. And it's possible it will freeze again, but okay, I might have to restart. All right, so if it doesn't finish, you can close it. Which one? If it takes too long, yeah. Okay, if you reopen and go to recent projects and the most recent one, it should take you back. Okay, they all ran. So if they all have checks, that means they all ran, right? Okay, let's look at the results of text cluster. Yeah, yeah. If it takes too long, just don't don't be patient with this. Just yeah. All right, text cluster results. Okay, so we get you can see that without any clear, there's too many. There's way too many clusters. There's like 20 or 13, and it's unclear what goes into what category. So let's narrow down the clusters. Right? So to do that, um, click on text cluster, and let's make some changes. Let's click on. Let's change. Oops. Sorry. Okay, text cluster. Let's change the max SVD resolutions to 20. Let's change exact or maximum number of clusters to exact. Let's change number of clusters down to 5. And let's change descriptive terms to 10. Okay, so we made these changes. Yeah. Text. Yeah, so SVD resolution is low. That was the same. Max SVD dimensions is 20. 20. Exact or maximum is exact. Number of clusters is 5. That's the same. And then descriptive terms is 10. Yeah, so it looks just like 10. Yeah, here you go. So this, it highlights it here. So 20, exact, 5, 10. Let's see. I don't know if I want. Okay. All right. Let's run it again and see what happens. Okay. So if it works, let's get the results of the new cluster, and you should get 5 clusters. We do. All right. So this is one cluster. This is another. So it looks like cluster 1, 42%. So this is like, let's see what it is. Restaurant service discount, high. So this looks like features of the restaurant or the gas station. This looks like easy access, hard pump, discount. These are things that have to do with paying for gas. These are like amenities, right? Shower, uh, dirty. Okay, these are things that like free stuff, free drinks, free shower. And this looks like parking and like uh, lots to park at. So it kind of it takes things that are similar and puts them in a category. Okay. And we got 5 clusters. Okay, next thing. So utility. Okay, metadata. Drag that down there. Let's connect text cluster to metadata. Okay, so metadata, properties, variables train, and open this up. Okay, and we need to make the changes that we see here. So we'll change these under hide, change these ones to default and all the probability ones to yes. So make these changes you see in this little printout. And specifically, so let's see. Um, okay, so text cluster is an input, and text cluster probability is yes, yes, yes. Oh, how to get, okay, so metadata, and then over in properties, where it says variables, and then train, click on this button. Yeah, train. Okay, and then you want to change the role of text cluster to input. Oh, I meant there's some other things. No, never mind. Okay, so the new role of text cluster is input, and these are changed to yes. So the hide, yes, 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 yes. So this is changed new role input, and these are changed hide to yes. It's input. Yeah, so this one's input. This is yes, this is yes, this is yes, this is yes, and this is yes. Okay? Text cluster, new role is input, and the hide probability of text cluster prob 1, 2, 3, 4, and 5 should all be yes. So you're hiding those. And this is now an input. And let's hit OK. Now let's drag a data partition node from samples. And connect it to metadata. Okay, and click on metadata, click on data partition, and let's change training to 80, validation to 20, and test to 0. So right here, data set allocations, 80, 20, and 0. Okay. Data partition property, data set allocations, training is 80, validation is 20, and test is 0. Okay, now let's drag a regression node from the model tab. All right, and let's rename this. So right click, rename, we'll call it numeric only, parentheses, reg, reg, okay. And let's connect that to data partition. Numeric only reg, and choose edit variables. Okay, we need to change the use of all of these text clusters. Oops. What just happened? Sorry. Okay, we need to change the use of text cluster 1, 2, 3 all to no. So this is no. This is no. Yeah. So all we changed here was the use of this, 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 and this. The use of all those are now no. Yeah. Okay, let's Okay, so we made these changes, right? Okay, so let's hit, I think I did it. Let's hit okay. Click on the numeric only reg, and under properties, let's change the selection model to stepwise and the selection criterion to validation error. So selection model is stepwise and selection criterion is validation error. Yeah, so this is stepwise. This is validation error, and that's all we did. Okay, so on the reg, selection model stepwise, and selection criterion is validation error. Okay, now we need to make another regression. So right click this one and choose copy, and then paste it somewhere. Okay, let's call this one numeric and text reg. So right click, rename numeric and text reg, numeric and text reg. Okay. Partition node. choose edit variables. All right, and let's change the use role of cluster membership from no to default. What? Oh, text cluster. This should now be default. Okay? Everything else is the same, but text cluster, the role now, the use is default. And hit OK. Now let's add a third regression. Yeah. Okay, everyone good? Right click either one of these. No, let's right click this one. Copy. And paste it somewhere. Okay, and let's call this one numeric and SVD reg. Numeric and SVD reg. Okay. Let's connect this one. Okay. Let's right click this numeric and SVD reg and do edit variables. Okay, we need to change the use of all the text cluster SVDs back to default because we're going to use them now with the SVD. So these are all now default. And this is no. Okay? So from here on out, or from this side, you should see target is yes, text cluster is no, and everything else is default in the use. Okay? Okay. Now let's get a model comparison node from assess and drag it over there. And let's connect all the regressions to the model comparison like this. Oops. Okay, let's run this. Probably gonna freeze, but looks like it finished, but no, not finished. Okay, I'm gonna relaunch. Okay, okay, so everything ran. Let's get the results. Okay, so which one was the best? Looks like numeric and SPD was misclassification rate of about 29%, numeric and text about 36%, and then this one, numeric only 40%. So this one looks like, if you're comparing the misclassification rate, that looks like the best one. Numeric and SPD reg. Did we get those numbers? Yeah, 0.29, 0.36, and 0.4. Okay. Yeah, the document has different numbers, but close enough. Yeah. All right. Now just the questions. Okay, everybody got this? Yeah. All right, so we get that. Okay, so research or the case questions. So after step 11 in page 4, you see the descriptive terms for each cluster. Briefly categorize each cluster based on those terms. And then from a marketing manager's viewpoint, which cluster may guide you in developing promotional strategy. So let's look at the um, cluster node. Okay, so if you go to text cluster and right click and results. Okay, and so all the question is just asking you to take these 5 clusters with the descriptive terms and just give a general title to those clusters. So this is like um, food service. This one's probably like um, gas discounts or gas rewards. This one looks like amenities, like showers and this one looks like free stuff. And this one looks like parking and like space. So something like that. Okay. And from a marketing manager's viewpoint, which cluster might guide you in developing promotional strategies? So if you're looking for promotional strategies, you're going to look at things like coupons, um, or free things. Like you can't really get promotions in parking or um, amenities. So yeah, one of those. Okay, and then the current case study shows 3 models. Add your model that may improve the model fit, including textual comments, and then explain your model and report the fit. So all you got to do, so the best one was this one, right? So just start with the one that's the best or the lowest classification rate, and maybe make just one or two changes. So let's go ahead and just copy and paste this one. And let's call this numeric and SVD reg 2. Okay, let's connect it. Okay, and connect it to the model comparison there. And just change something in the properties, like maybe maybe have it give polynomial terms. I don't know. Here's so just change something in the features and rerun it. So I'm going to change polynomial terms to yes with polynomial degree 2. And let's rerun the model comparison. Ugh. Does it do this every time for yours? Yeah, it never. Yeah. Oh, so I changed polynomial terms to yes. That was it. And then, yeah, it's time to. Um, okay, so results. And looks like that one was second best, right? So the polynomial didn't help the improvement of the model, but you can see it there. So there's the 4. Okay, let's save this. So go to the model comparison node and right click, create model package. And you can call this first name, last name, case analysis 2. Okay, then you can save your model package. You can right click the name, save as, SPK file, and you can call it first name, last name, case analysis 2. So the SPK file. And then you can also save an image of the model diagram. So click on, under diagrams, click on your case study or the name of the diagram, and then right click, save as, and you can save it a .gif, which is just an image. Okay, so first name, last name, case analysis 2. Okay, so for case analysis 2, the SBK file, the GIF file, then the answers to the case questions. Okay, and that's it. Okay. Questions on this? Okay, so these two are both, you can email these two for this one, and these two for this one, or these 3 for this one, and then that's it. So everyone's here. I don't need to take attendance. We're overdue already. What's up? Oh, maybe. Yeah. Okay. So anything else? And then I'll post the